So we're going to go ahead, we're going to solve this system of equations. And the students in machine learning will have seen how to do this through the use of specifically working with an augmented matrix, I assume, or through working with a matrix inverse. In this particular case, it doesn't look too terrible to set this up with an augmented matrix, because it looks like, yeah, we can probably sneak through this with an augmented matrix. So let's go ahead and set up the augmented matrix. So we have 2, -4, 5, and -33. We have 4. Look at that. That's so sneaky. 4, -1, 0, -5, -2 to -3. I always actually really disliked it when my teacher would do that to me when I was an undergrad student. I was like, why don't you just align the things where they should be? Right? Like, put a space there. Like, align the x's, align the y's, and align the z's. Okay, we don't have any leading ones in this particular case.
Brace yourselves, everyone!
Hey! Welcome on in, Raiders. My name is Penn Center, and today we're doing some mathematics. We are working a little bit with machine learning, specifically the linear algebra component required to understand machine learning at a bit of a deeper level. So we're solving some mathematics questions there for our students at the college. And then at 1 o'clock, we're actually going to be reviewing our very first test for algorithms, encryption algorithms, for our data science students. So they don't know that we're going to be going through that test, but they just had their test yesterday. I'm going to make a solution key today because I haven't had time to do that yet. So welcome on in. Thanks very much for the raid and Simplex Raiders. How are you doing? So here, I don't have a leading one. I don't particularly want to make a leading one yet, so I'm going to skirt around having to make a leading one until later. So I'm going to do something like this. I'm going to say, okay, let's take row 2 and subtract 2 copies of row 1. And let's take row 3 and add to it a single copy of row 1. This will give us a brand new augmented matrix that's similar to the previous one in solution. So what do I need to do here in row 2? So 4, take away 2 copies of 2. That's going to give me a 0. -1, take away 2 copies of -4. So this is like -1 plus 8, or 8 minus 1. So that should give me a 7. A 0, take away 2 copies of 5. Sounds like -10. And then -5 plus 66. So I have 66 take away 5. 61. Gross. 2 and -4. So -4 plus 2, -3. So 5 take away 3 is what we have here. So that's 2. And then we need to add -33 and 19. That one, I'm struggling with that one. This is like almost like taking away 20. So we're going to be in that -13 range, aren't we? So -33 plus 19 is -14. Okay. Okay. So for me, that seems like a pretty reasonable step number 1. Now, I don't really want to take row 2 and divide by 7. So what I'm probably going to do is I'm probably actually going to swap row 2 and row 3 so that I can divide that third row by -2 to get a leading one that I need in order to get my reduced or echelon form. That to me just feel like I'm really just trying to prevent having to use fractions. That's really the key in this particular question. So let's swap those 2 rows, -14, and we get 0, 7, -10, and 61. And then I'm going to take row 2, and I'm going to multiply it by -1/2. Right, so I can basically multiply any row by a non-zero number, and so we can effectively say that we can divide also by a non-zero number. So let's just divide by -2. Let's get our leading one. And then we should hopefully be able to start kind of canceling out the numbers that are above and below the -2. Okay, so does that change how we want to tackle these next row operations? The problem is solved, the question isn't yet. Wah, wah. Yes, very true. Thank you. Thank you, Jed. I appreciate your antics. We appreciate, we do not discriminate against dad jokes here. we treat all dad jokes as equally as other dad jokes. So if we go row 1 plus 4 row 2s, that should still give us a 2, a 0, and then now it's going to turn into 5 minus 4, which is 1. Negative 33. No change to row number 2. And then this should be 0, 0. So we need negative 10 plus 7, which should be negative 3. And then 61 minus 49. So 61 minus 49. Okay, so we still get actually something really, really nice here in row 3. I can still now divide by a integer number, and we are going to get our final leading one, or our third column leading one here. So I'm just going to go ahead and copy down. What is going on with this? This negative 5 just doesn't want to participate. What's happening? So our third row should become 0, 0, 1, and then we should get a negative 4 here. So that looks a little bit better. Now all we need to do is just clean up. We go row 1. This is going to be a subtraction of row 3, and then we need row 2 with an addition of row 3. That should clean up everything and hopefully get us to some kind of reasonable final answer. So that's going to give us pretty close to reduced or echelon form over here. So let's see what the constants are. So negative 4. We have negative 5 plus 4. And we have 7 minus 4. So I think that looks a little bit better, right? Is my stylus running out of ink? Oh my god. Oh my god. Maybe it's running out of charge. Okay, and then the last step here is we'll take row 1. Let's go ahead and divide by 2. So that will give us our complete reduced row echelon form and hopefully match up with the answer that we have online. So x, y, and z should be completely given by negative 1/2, 3, and negative 4. And I think that was the answer that was given to us online, right? Negative 1/2, 3, and negative 4. Perfect.